While not all leaks can be sealed when they are found, we're going to look at a case study where it was possible to not only identify the source of the leak, but also measure the impact of repairing it. The condenser shown here is a combined cycle unit. There is only one vent line. You can see the steam turbine exhausting into the side of the condenser. The vent line runs across the top of the condenser over to a bank of two pumps. Due to limitations on space and access to the lines, a single RheoVac probe system was used. This meant that the search area could not be as easily localized. However, it is a much smaller condenser than a typical coal or nuclear unit, meaning that the entire unit could be checked with helium in one day. This is a plot of the data that was collected by the RheoVac system during the testing. The plot line color corresponds to the matching axis color. So when looking at a specific plot line, you will need to look at its matching colored axes for the corresponding numerical value. Upon arrival at the site, the unit was running with 50 SCFM of air and leakage. The mass ratio was well below 3. And using the helium leak equipment, a large leak was found and was able to be temporarily patched. The total air and leakage dropped by 30 SCFM, and the pressure dropped by approximately 0.2 of an inch. Following the leak fix, the air and leakage has dropped to 20 SCFM and the mass ratio is above 3, indicating that the stagnant zone has been removed from this condenser. A stagnant zone is caused when the air and leakage is above the exhauster capacity. The leak that was found and temporarily patched was on the hood spray pipe seen here. This is a high vibration area, and several of the other units had started to show cracking of these hood sprays. This plant has 4 identical units, and the action taken was to replace this connection with the flex line. This leak accounted for 30 of the 50 total SCFM. The unit also had leaks at the expansion joint and surrounding a drains tank that accounted for the remaining 20 SCFM. The drains tanks at this plant have a history of issues due to high vibration and extreme temperature swings that have caused stress cracking in the tank bodies. The bottom line is that as a result of the testing we performed, this plant was able to mitigate 2 major sources of air and leak and avoid potential problems because we were able to locate and quantify both sources. This could not have been accomplished in such a short time without the use of the RheoVac in conjunction with the helium detector.